This video is presented by Squarespace, a universal platform for creating your brand and growing your business online. The object in question is likely more massive than Earth, but slightly less massive than Neptune. He is somewhere between earthly and giant icy planets. His orbit, unlike the orbits of known planets, is far from circular and flat. Instead, it is exceptionally wide, 20 times the orbit of Neptune. This is just a tiny point, a faint glowing object hidden in old telescope data collected during two astronomical surveys conducted 23 years apart. Nevertheless, this weak point can become one of the most significant discoveries of our time. Because if this is indeed what scientists suggest, it could be the long-discussed Planet 9. But why do astronomers even believe that Planet 9 exists? In 1781, English astronomer William Herschel scanned the sky using a telescope he built himself. He was searching for comets, but instead stumbled upon a new object that didn't quite behave like a comet. Over time, astronomers realized that this object orbited the sun like a planet, slowly, steadily, and at a great distance. It was named Uranus. However, with increased observations, astronomers noticed that Uranus was not moving as Newton's laws predicted. Its orbit wobbled slightly, but enough to raise questions. The French mathematician Urbain Le Verrier figured this out with pencil and paper and concluded that there might be another planet influencing Uranus. He even calculated where this mysterious planet should be located, based solely on the strange behavior of Uranus. And when the astronomers pointed their telescopes to the specified point in the sky, miraculously, they found Neptune exactly where it was supposed to be, according to calculations. Now let's move to the year 2016. Two scientists, Mike Brown and Konstantin Bodygin, from the California Institute of Technology, noticed something strange. They were studying the orbits of several distant objects in the Kuiper belt when they observed a certain pattern. These orbits were not random. They were grouped, leaning in one direction as if something massive was pulling them. When Mike and Konstantin analyzed the data, it led them to an unusual possibility. The only thing that could explain the strange orbits of these Kuiper belt objects is a hidden planet, 5 to 10 times the mass of Earth, located far beyond Pluto, at such a distance that we may never see it in visible light. They named it Planet 9, and since then, astronomers have pursued it, chasing shadows at the edge of the solar system. Now, the farther the object is, the harder it is to see, especially if it does not reflect much sunlight. Therefore, to find Planet 9, scientists have begun searching in two infrared sky surveys. One was conducted by the IRS satellite in 1983, and the other was the Akari mission of Japan from 2006 to 2011. This led us to the recent events. A team led by an astronomer from National Tsinghua University in Taiwan did something clever. The researchers were looking for objects that were found in both surveys, but not in the same location. The idea was that if something shifted slightly between two time periods, it could mean that the object was slowly moving in orbit around the sun. However, this is not like tracking a comet racing across the sky. If Planet 9 exists, it moves at a speed of about 3 angular minutes per year. This is very little. In comparison, a full moon spans about 1,800 angular minutes in width. So how can something like this be noticed? Here, parallax comes to the rescue. For example, when you hold a finger in front of your face, close one eye, and then switch to the other, your finger seems to shift sideways. This is parallax. In space, we use Earth's orbit around the sun to create a similar effect. Observing the sky from different points in Earth's orbit, astronomers can notice slight changes in the position of distant objects. Over time, these shifts can be used to assess the distance to the object and its movement. Based on this, the team searched for objects that appeared in the same place at the same time every year, eliminating the influence of parallax. They then narrowed their search by checking if these objects shifted slowly over time. In the end, they found one object, a weak point in the IRA data from 1983, and another point located 47 angular minutes from it in the Akari data from 2006. Could it be the same object? Could it be Planet 9? Perhaps because, judging by its brightness in infrared data, it should be more massive than Neptune. And what will happen next? With their artificial intelligence, creating a unique digital identity becomes engaging, easy, and fast. Their web design system called Fluid Engine allows customization of every design element using user-friendly drag-and-drop technology. Built-in analytics tools are also available so you can easily track who visits your new page. Now, let's return to Planet 9. If we roughly know where it was in 2006, we can try to discover it again using powerful optical telescopes. But here is the problem. Since Akari discovered this object, it could move, and we don't know where exactly. But we have tools that can help. For example, the Dark Energy camera in Chile has a wide enough field of view to scan the necessary area of the sky. Soon, the Vera C Observatory, Ruben will begin his work and propose even deeper and broader studies of the sky. Thus, it is quite possible, even likely, that if this object is real and still faintly glowing, we will see it again. However, not everyone is sure about this. Mike Brown, who helped propose the Planet 9 theory, examined the data himself. While he does not completely rule out this possibility, he is skeptical as the orbit of this supposed object does not match expectations. Planet 9, as predicted, should have an orbital tilt of about 15 to 20 degrees relative to the plane of the solar system. The tilt of this new object appears to be more like 120 degrees. This means that it is not just tilted, but moving in the opposite direction compared to most planets. According to Brown, this does not mean the object does not exist, but indicates that it is not Planet 9. What do you think? Just because we found something unusual, it doesn't mean we discovered what we were looking for. In any case, one thing remains clear. This mysterious point, whether it is Planet 9 or not, will occupy astronomers, because somewhere out there, in the cold and darkness, something is moving. Nevertheless, there is another explanation for the strange orbits of Kuiper Belt objects that does not require the existence of Planet 9. Perhaps our solar system had an incredibly close encounter with a passing star, not with one, but with two recent studies. It has been suggested that a stellar encounter could explain the strange orbits of some objects at the edges of our solar system, as well as the unusual moons orbiting nearby planets. This encounter, according to research, was remarkably close. A wandering star passed at a distance of 110 astronomical units from the Sun, meaning it came 110 times closer than the distance from the Sun to Earth. In comparison, this star would come closer to us than the Voyager 1 probe, which is currently 164 astronomical units from the Sun on its journey beyond the solar system. Considering that the nearest star to us, Proxima Centauri, is more than 4 light years away, this was an incredibly close encounter. Researchers suggest that such a close approach was necessary to explain the unusual and chaotic orbits of celestial objects located in the farthest regions of our solar system beyond Neptune's orbit. To determine whether the gravity of a passing star could be responsible for the strange orbits of some trans-Neptunian objects, scientists conducted over 3,000 computer simulations. Their results not only confirmed the hypothesis but also revealed something interesting. Simulations showed that this stellar encounter could explain two of the most unusual trans-Neptunian objects with retrograde orbits, meaning they move in the opposite direction of the planets. This may also explain the distant dwarf planet Sedna, whose orbit reaches 937 astronomical units from the Sun. One of the co-authors, an astrophysicist, noted that the simulations indicated a star slightly smaller than our Sun, with a mass of about 0.8 solar masses, which passed at a distance just under 4 times the distance from the Sun to Neptune. Interestingly, this event could also explain the strange moons in our solar system, such as Phoebe, the moon orbiting Saturn, which has a retrograde and distant orbit. Similarly, Jupiter and Neptune have several irregular moons that could be trans-Neptunian objects displaced by the gravitational influence of this stellar flyby. This may explain why the outer planets have 2 different types of moons: regular satellites that formed alongside planets and have stable, predictable orbits, and irregular satellites that have strange or retrograde, meaning backward orbits, and may have been captured from the outer part of the solar system. If this star had a close encounter with our solar system billions of years ago, it could have been a remarkable chapter that might have gone unnoticed. What do you think about this? Write in the comments so I know. In the meantime, we found something strange at the edge of the solar system. Launched in 2006, NASA's New Horizons is one of the fastest spacecraft ever built, flying through space at speeds of over 36,000 miles per hour. His main task was to explore Pluto, once a mysterious icy world hidden in the dim outskirts of the solar system, over 3 billion miles from the Sun. In 2015, New Horizons made a historic flyby of Pluto, revealing a landscape resembling something out of science fiction, with towering icy mountains, plains of frozen nitrogen stretching for hundreds of miles, and glaciers appearing to flow like rivers. But New Horizons did not stop at Pluto. The spacecraft continued its journey into the mysterious and largely unexplored Kuiper Belt, a colossal ring of frozen bodies and ancient debris that surrounds the Sun beyond Neptune. This vast region, stretching an astonishing 2 billion miles, is a frozen graveyard of solar system formation, scattered with icy rocks, dwarf planets, and comets that have remained in deep cold for billions of years. In 2019, New Horizons made the farthest flyby in history, passing by Arrokoda, a strange object resembling a flattened snowman. This strange reddish object, formed from two smaller bodies that gently merged, provided scientists with a direct view of the building blocks of planets. Today, over 5 billion miles from its home planet, New Horizons continues to send data, transmitting faint signals that reach Earth in over 6 hours. But the spacecraft's work is not yet finished, and it moves deeper into the solar system. Currently, it is located 60 astronomical units from the Sun. 1 astronomical unit equals 93 million miles, which is the average distance between Earth and the Sun. At a distance of 60 astronomical units from the Sun, the spacecraft New Horizons made a revolutionary discovery, revealing something unexpected in the remote corners of the solar system. The vast distance of the Kuiper Belt from the Sun means that all objects within the belt are weakly exposed to solar radiation. This in turn means that Kuiper Belt objects have likely remained largely unchanged since the formation of the solar system about 4.5 billion years ago. This makes the objects of the Kuiper Belt ancient remnants of a cloud of material known as the solar nebula, from which the Sun and planets formed. Currently, to support the ongoing research of New Horizons at the edge of the solar system, astronomers on Earth are observing the Kuiper Belt using the Subaru telescope of the National Astronomical Observatory of Japan. To date, observations from Subaru have revealed 263 new objects in the Kuiper Belt. However, in an unexpected turn of events, a large international team of astronomers led by Wesley Fraser from the National Research Council of Canada discovered objects much further away, challenging our planetary models. Yes, signs of a hidden structure have been detected at the edge of the solar system. Observations showed that 11 of these objects are significantly farther than we assumed, beyond the Kuiper Belt, in an area more than 70 astronomical units from the Sun. But that's not all. Based on the number of objects found, researchers estimated the density of the outer ring of the Kuiper Belt. They discovered that, although it is lower than in the inner regions, it is still high enough to have or form new structures. And between the Kuiper Belt and the newly discovered structure, there is an area where almost nothing has been found. Yes, a mysterious gap. But is it really that mysterious? Although it may seem a bit strange, such gaps are common in other forming planetary systems, which compares our solar system to what we have observed in other parts of the galaxy. Many observations of the Milky Way suggest that our solar system is quite unique, as it is the only known planetary system with life. These unusual characteristics may play a key role in creating conditions for the habitability of the solar system. But if the discovery of this structure is confirmed by new observations, it will tell us that our star system is not as unique as it seemed. The Kuiper Belt of our solar system has long seemed very small compared to many other planetary systems, but our results suggest that this opinion may have arisen from observational distortion, Fraser explained. So, perhaps if this result is confirmed, our Kuiper Belt is not so small and unusual compared to those surrounding other stars. Yes, our technology for observing space has its limitations, which can lead to distortions that make certain characteristics seem unusual when they are not. If the new findings from the Kuiper Belt are confirmed, we can rule out one of these supposed anomalies, a smaller than expected solar nebula. To better understand this discovery, astronomers continue to track the orbits of these 11 distant objects. This groundbreaking discovery reveals something unexpected, new, and exciting in the far reaches of the solar system, said lead researcher Alan Stern from the Southwest Research Institute. This discovery would probably not have been possible without the outstanding capabilities of the Subaru Observatory.